exploring the nature of consciousness with category theory. This talk will introduce the fermionic mind hypothesis, and then I will show 3 examples that can verify it. What is consciousness? This is an age-old question, but recently neuroscience focused on certain brain structures or brain organization to explain it. However, with the emergence of AI, most experts believe that AI will be conscious at some distant future. And this indicates that consciousness is not connected to the neural tissue or the brain, but it is more of an abstract phenomenon defined by physical laws. And indeed, neuroscience turns to physics to explain consciousness. A prime example is quantum cognition, where a probabilistic nature of cognition, memories, decision-making, context dependence, superposition, or even entanglement can be found. And for example, a social laser has been utilized to explain social uprisings such as the Arab Spring. So, and later in the talk, I will show also the existence of wave-particle duality. In addition, classical physics has been also used to explain cognition. For example, sentiment contagion defines the spreading of attitudes and emotions on social media. A filter bubble is used also to define the ability of social media to enhance social bias within certain groups. Or hysteresis is used to explain aggravation and the delayed calming down afterwards. Also, the persistence of employment even after economy recovers after depression, or indeed the behavior of mob that takes time for these crowds to calm down even after the situation normalized. In addition, economy uses the easing model to study investor behavior, for example. The fermionic mind hypothesis goes a step further, although it builds on these ideas. It looks at the brain as a coherent abstract mirror of the environment that must adopt all the physical laws in its intuition of the environment to produce intelligent response to the stimulus. And in this process, consciousness becomes a particle-like and fermionic entity. So what is a fermion? The fermion um, is a half-spin constituent of matter in a very simple definition. And half-spin comes from 100-year-old experiment that used silver atoms, projecting them into a magnetic field and finding a discrete separation into so-called upspin and downspin particles. I will show that this very same phenomena is true for the consciousness as well. So the brain, we must start as the brain be part of the environment. Stimulus comes in, response changes the environment, but the brain also changes, causing their parallel evolution. However, the brain itself forms a thermodynamic cycle during perception or cognition because it builds on the resting state. It forms this resting state in the absence of stimulus. The brain's energy supply is tremendous, but it mostly, overwhelmingly, is used to maintain the neurons' ability to form activation and recover their resting potential. Also, on the organizational level, it maintains the resting state. So in this way, it ensures the flawless transmission of information throughout the brain, pretty much like the oiling of the mechanical engine. When stimulus arises, it activates the brain, triggers perception and response until the resting state returns. And this endothermic cycle, of course, builds intellect in as synaptic complexity. But earlier experiments show that the brain can form not only endothermic but also exothermic cycle. And these two are diametrically opposite conditions. The endothermic cycle requires an energy input, but it builds energy as intellect, whereas the exothermic cycle releases energy into the environment. So these represent discrete conditions analogous to upspin and downspin. Indeed, in learning process, beginning with Pavlov, the reward conditioning represents an endothermic condition. And this is the same in AI, where the reward function plays the same role. And of course, failure would represent an exothermic condition. If we summarize these ideas, then we can see the brain in the environment and as it forms endothermic or exothermic process. Shannon, who studied information entropy, noted already in the late 1940s that an endothermic information cycle represents future orientation, whereas the exothermic cycle represents past orientation. And if we look at this, in practice, then we can see that the brain accumulating complexity, intellect, represents future orientation, openness, trust, confidence, contentment, creativity, and can accumulate over time. Indeed, this is probably the basis of healthy intellectual state, whereas exothermic processes lose energy and create anxiety, repetitive thinking, remorse, impulsivity, insecurity, and other adverse conditions. So half spin has an immense importance in the physical world. Through the Pauli exclusion principle, it leads to the structure of the atomic orbitals and the incompressibility of matter, whereas in psychology, it forms psychological spin, which gives a structure to society. And in any economic system throughout history, the inequality was increasing over time through to this comparison, competitiveness due to the psychological spin, and it manifests the territorial needs of animals and also the need for personal space for people. Now I arrive to the second part of my talk, the verification of the hypothesis, and I have 3 examples that I will show. And the first one is the pinhole camera. The second, the temporal nature of consciousness. And finally, I will introduce consciousness as a fermion. And I use category theory from abstract mathematics, which can ignore the local qualities of objects and categorizes them based on their relationship to other things. And this way, we can recognize the fundamental identities between objects. So my first example is the pinhole camera. That is a box with a tiny hole on its side, and it projects an upside down inverted image in the back wall from a lit object. And in the brain, decaustation plays the same role, whereas the stimulus from the environment crosses in the brain stem, and it projects an upside down and inverted image on the cortical surface. So this is the left image from the left-hand side is projected on the right cortical surface, and vice versa. This is the same for the motor cortex. And we can draw a diagram based on this from category theory, where if we mark the sensory object with F and the projection with a G, then we can see that it doesn't matter whether the F is projected to through the pinhole of the pinhole camera or through the causation. The end result will be a upside down inverted projection, even though the details of the system is very different. And now I want to talk about the temporal nature of consciousness. A stimulus is a spatial relationship, but the sensory system turns it into a temporal rhythm, which is followed throughout the cognitive process in memories, thoughts, speech, muscle activation. And this way, the brain is projected as a mind that is that contrasts from the brain. The brain is material substance located inside the skull, while the mind doesn't have a physical location. Instead, it represents some sort of temporal flow of events that exist throughout time. Indeed, while the brain can be divided into smaller and smaller parts, the mind can be divided by cutting the corpus callosum into the split brain experiment, but cutting the brain further destroys consciousness. So the mind is the smallest unit of intellect. So consciousness is really a unit of this intellect, and the experience of now is a continuous flow. But when we look at consciousness in time, memories materialize in discrete points, and predictions also represent some points in the imagination in the future. This, I argue, is a duality that is analogous to the wave-particle duality in quantum mechanics. Now, the third part of my talk will show that consciousness is nearly identical to fermions. In category theory, isomorphism is a connection of elements in two categories when one element correlates with just one element in the other category, and all the elements are represented in the comparison. So this way, when we look at the characterization of consciousness and fermions, we can see that both can be characterized by quantum mechanics. Both are form spin, and both are the unity is a characteristic of both, and both have very specific classical features that show great similarity. And this is another representation of their similarities. Nevertheless, if we looked at the details of consciousness and the fermions, they would be very different. consciousness is formed in the neural tissue, while fermions are tiny elements of matter. So if we go back to the question I asked at the beginning of this talk, we can answer what consciousness is. Consciousness is the awareness of being separate from the environment. And this separation is a discrete particle-like state of the fermionic mind, where the resting state represents a self-referential equilibrium, which is constant throughout life. Indeed, people recognize us even if they don't see us for decades. And we consider ourselves the same from birth to old age. Discrepancy with expectations, for example, triggers emotions that motivate behavior to restore some kind of psychological balance that is determined by culture, economy, national identity, group identity, and experience. The perception cycle or cognitive cycle is reversible, that gives rise that probabilistic contextual character. And this is also analogous to the wave-particle duality known from quantum mechanics.